Hello friends, welcome to the video lecture series of statistics and probability. So far, we discussed various distributions, random variables, then many measures we discussed in previous lectures. The measures of central tendencies, the measures of dispersion, that is standard deviation, mean deviation. Now, we are going to study the important parameter describe the data. Because if the data is normally distributed, it becomes simple to handle it. If the given data points or the data is not normally distributed, if the data is accumulated on the right hand side of the mean, if data is accumulated on the left hand side, if the data is more picked at particular level, in that case, the measures of bigness and the measures of skewness that we are going to study today. Means the skewness and the measures of bigness, that is kurtosis. Skewness and kurtosis we are going to study. And the one more thing we are going to discuss, that is the moments. In engineering mechanics, the moment is the measure of energy which generates frequency. The similar kind of meaning is there in statistical moments. I'll call it as a moments or statistical moment. In statistics is the same thing. Yes, what is the moments? Rth moment about arbitrary point, say A. It is summation x data points minus A, this power R divided by N. N is what? Sum of the data points. If data points are 100, N is 100. If the frequency table is given, in that case, you have to multiply this bracket by F only. Then Rth moment about the mean. The mean of the data point, say x bar, then summation x minus x bar power r, this divided by. Here, Rth moment about mean and Rth moment about an arbitrary point. Is for the sake of simplicity, is I will denote it by mu dash r, and here I will call it as mu r. Now the moment about the origin. Moment about the origin. There are normally three types of moments are studied. Moment about the origin, moment about an arbitrary point, and moment about the mean. The moment about the origin, here in place of A, you have to put 0 only. Now, the moments about the mean and moments about the arbitrary point, there is a relation between these two. Now, first moment about the mean, that is mu1, and summation x minus x bar, this is Rth moment formula, put r equal to 1 simply, this by n, and first moment about the mean is 0. Normally in moments, first four moments are important. The first moment about the arbitrary point, it indicates the mean. Second moment, variance. Third moment, it is related to skewness, and fourth moment related to the kurtosis. The first moment about the mean is 0. We can easily show it. Means summation of x by n. I am separating denominator here. Summation of x bar by n. Summation of x bar by n is the mean itself, is it? Minus. And summation of all mean divided by n, again x bar, and it is equal to what? 0. Means moment about the mean is always 0. First moment about the mean is 0. Now, the second moment, just you put r equal to 2. Second moment about the mean of the data, it is mu2 equals summation x minus x bar square, this divided by n. As I told you earlier, if the frequency table is given, then this must be multiplied by f only. And in the denominator, summation of f is n. Okay, throughout the chapter, this summation of f is equals n. This you have to remember. Okay, this is standard notation. Summation f is n. Then it represent. This represent the variance now. Second moment, and third skewness. First of all, I am going to write third moment about the mean. Moment about the mean. Simply substitute mu3 equals summation x minus x bar power 3 by n. And fourth moment about the mean, mu4 equals summation of x minus x bar power 4, this divided by n. Okay, these are the first four moments about mean. And first four moments about arbitrary point, you can find by this way. Put R equal to 1, 2, 3, 4 and so on. Now coming to this skewness. This skewness measures the lack of symmetry, you can say. It measures the lack of symmetry. Up to which degree the data is not symmetric. It is measured by skewness. In skewness, in normal distribution, if the curve is normal distribution, if the data is normally distributed, the mean is equal to mean, mode of the data and median of the data. They are same. If mode is greater than mean, this implies the curve is negatively skewed. Means if the data is like this, see, this is normally distributed, this is normal distribution curve, and the data is, if it is negatively skewed, in this way, this normal distribution curve. In short, I am writing normal curve. Here the data is left skewed, means on the left hand side of the data, this will be like this. Okay, this is the asymptote. This horizontal line is asymptote to the curve. We have mean of the data and this median of the data. This is median. This is mode of the data. And median will lie between mean and mode. Here, median will lie between mean and mode somewhere else. Here, mode is greater than the mean. The data is negatively skewed. Means on the left hand side, it is skewed. Now, the positive skewness here, I am drawing here 3 curves so that it will be easy to compare. If the data is like this, here this is the mean at this point suppose, and mean is greater than a mode, the data is positively skewed. Okay, it is positively skewed data. For normal, okay, mean, mode, median are same. When mode is greater than mean, then it is left skewed. If mean is greater than mode, then data is, or the curve is positively skewed. Now the coefficient of skewness and kurtosis you can find out. Here the coefficient of skewness can be found out using this formula, mean minus mode divided by standard deviation. Okay, this is sigma. The sigma is the standard deviation. This formula can be replaced by 3 times mean minus median, this divided by standard deviation. The coefficient of skewness can be found out using this formula. Yes, it may happen that if mean is given, mode is given, mean of the data, mode of the data is given, standard deviation of the data is given. So you can find out coefficient of skewness. Put down the value and get the answer like that. If coefficient of skewness is given, out of this 4, 1, 2, 3, 4, coefficient of skewness, mean, mode and sigma. Sigma means standard deviation. Out of this 4, if 3 things are given, so you can find out 4th one. Here out of this 1, 2, 3, 4, if 3 things are given, the 4th you can easily find. Now, here the coefficient of skewness can be, measure of skewness also I am writing. The measure of skewness, it is denoted by beta 1, normally. And this beta 1 is equal to mu 3 square by mu 2 cube. Yes, what is mu 3 and mu 2? The mu 2 is second moment about mean and mu 3 is third moment about mean. And from here, the coefficient of skewness also you can find out. Either you find out coefficient of skewness from this information or coefficient of skewness you can find out from beta 1 also, from the measure of skewness. Coefficient of skewness I am denoted by gamma 1 and it is under root of beta 1. This is all about the skewness. Whether the data is skewed on the right hand side or left hand side, that can be judged using this formula. Now, coming to the kurtosis. Kurtosis is the measure of pickness. Kurtosis, it is how much the data is picked, that we come to know from kurtosis. It's many times, okay, you may come across this type of situation. See, the 3 curves I am going to draw, and which is more picked, that I am going to tell you. Okay, this middle one is what? It is a normal curve. This curve is a normal curve. If curve is normal, then we should not worry more. Now, here, this curve is more picked, like this I am going to draw. It is the pickness is more. Okay, pickness is more. This curve is less picked. This is described by the kurtosis. This is normal curve, or this is mesokurtic curve. Okay, this is less peaked, this is platykurtic curve. Normal curve is mesokurtic, then the platykurtic, and now this is more peaked, this curve and this curve is leptokurtic. Which one? Yes, this is leptokurtic curve. Here peakness is more than the normal. Here for normal curve, the peakness is standard. This curve is mesokurtic and this is less peaked. Peakness is less. This is platykurtic curve. In short, I am going to write. I will tell you what is beta 2. Here beta 2 is less than 3. Here beta 2, when curve is mesokurtic, it is 3. And here beta 2 is greater than 3. Okay, I will tell you what is beta 2 and how to find out the value of beta 2. Okay. Now, the degree of weakness we are going to calculate like this. Now, measure of kurtosis formula I am going to write. Measure of kurtosis. The measure of skewness we have written. Now, the measure of kurtosis formula, and this is denoted by beta 2. Now, the measure of kurtosis I am denoting it by beta 2, and it is equal to mu 4 is divided by mu 2 square. Mu 4 is fourth moment about the mean, and mu 2 is second moment about the mean. Coefficient of kurtosis is up to which degree it is picked. If you want to find out it, this is gamma 2, it is under root beta 2 minus 3. Okay, this is the measure of kurtosis. And if you want to measure up to which degree this thickness is there, then coefficient of kurtosis gamma 2 is beta 2 minus 3. Now, so when we solve the problem of the moment, in those problems, we have to find out the measure beta 1 and beta 2 also. That's why I explained what is kurtosis and what is the skewness. Skewness refers to it describes the how much the data is left skewed or right skewed. In kurtosis, how much the data is picked. Okay, that we get. Now there is a relation between that relation also I am going to write, because when we solve problem, relation between moments about the arbitrary point. You can say it is arbitrary point or working mean is the same thing. Arbitrary point and moment about mean. Moment about mean. The relation I am going to tell you. What is the relation between these two? Mu r dash, relation between mu r dash and mu r. That I am going to tell you. Okay, this is the problem. See, these are the relation between moments about mean and moments about the arbitrary point. Now very quickly, one problem we are going to solve. It is already written on the sheet. Very quickly I am going to explain. Okay, this data is given to you. In examination, you may be given different data, These data points are given 5, 7, 13, 24, 29, up to 50. And their corresponding frequencies are given. Means in that particular data, 5 occurs 4 times, 7 occurs 6 times, 13 occurs 17 times, and so on. 50 occurs 2 times. Okay, this data is given. What is the question? Find the first 4 moments about the mean. This we have to find. Comment on skewness and kurtosis. Means here we have to find out the moment about the arbitrary point, moment about mean. Skewness means beta 1 and kurtosis means beta 2 also we have to find. We have to comment on it. Now, this is the table. What I am going to let here, let x is equal to or a is equal to 24. This is, you can say, the arbitrary point of the data. Arbitrarily you can take any point. Or the working mean ones. Okay, if the arbitrary point is given to you, no problem. Here the arbitrary point is not given. I have chosen 24. As far as possible, you try to select. If it is not given, arbitrary point is not given, just try to choose the entry which is in between this. Instead of A equal to 24, you can take A equal to 29 also. You can take A equal to 13 also. But for better accuracy, if you find out by taking middle value as far as possible, then it will be good. But you can take A equal to 24, A equal to 29, A equal to 13 and A equal to 36, any point. These two columns are as it is, see. Then this deviation I am taking. Yes, what is the role of deviation? If deviation allow our data to shrink, it requires, computationally it is more economical if use the deviation. Okay, it is good habit to use the deviation always. The D equals x minus 24. This x minus 24 means 5 minus 24, 7 minus 24, 50 minus 24, like this. Now the one column is required f into d, because these are the formulae we have to apply. These are the formulae we have to apply, and we have to find out the moments about the working mean or moment about the arbitrary point 24. So that's why all these columns are required, f into d. F into d means this column multiplied by this column, respective entries. Product of these two is minus 76. Product of 18 into 5 is 90. Product of 2 into 26 is 52, like this. F d square. Take square of d and multiply by f. Is, for example, minus 19 square into 4 is this one. Minus 17 square into 6 into this one. Minus 11 square into this. Minus 11 square is 121. 121 into 17 is this one. Like this. Now fd cube. Taking cube of it, multiplied by f, you get this one. Taking cube of it, multiplied by this, you get this one. F d raised to 4, f into d raised to 4. The take fourth power of this, minus 19 raised to 4 into 4 is this one. Minus 17 raised to power 4 into 6 is this one. Likewise, minus means 26 raised to 4 into 2 is this one. And these are the columns which are required to find out moment about the arbitrary point, mu1 dash, mu2 dash, mu3 dash and mu4 dash. And sum of fd, summation of all, here I have written. Summation of all these entries I have written. Sum of fd cube I have written here, means sum of all entries. Sum of all those entries I have written here. Summation of fd raised to 4 means sum of all those entries. Now, these are the formulae for moments about the value 24. The mu1 dash is summation fd by summation f. Summation f is capital F, mu2 dash is this, mu3 dash is this, mu4 dash is this. Just putting those values here. Summation fd 128 by summation f is 96. 128 by 96 is this. Summation ft square means this entry divided by 96 is this one. This entry divided by summation f is this one, and this entry divided by summation f is this one. In this way, mu1 dash, mu2 dash, mu3 dash and mu4 dash, all those are moments about 24, moments about the arbitrary point we are for. And the relation between moments about arbitrary point and moments about mean is there. This relation you have to remember. Moment about mean is always 0, means mu1 is 0. This is the formula for mu2, formula for mu3, formula for mu4. Put all those values here and try to find out it. Mu2 is this, mu3 is this, mu4 is this, and mu1 is always 0. Okay, these are the moments about mean. These are the moments about the working mean or arbitrary point 24. Very quickly, next one. Here, the data is not given directly. Moments about, first 4 moments about the working mean or arbitrary point 5 is given. This moment, first moment is 2, second is 20, 40 and 50. These are the moments about the arbitrary point. What we have to find? Moments, central moments. Central moments what? Moment about the mean, actual mean. Actual mean or mean is same thing. Moments about the mean we are going to find. Also find the mean of the data, standard deviation and coefficient of skewness and kurtosis. Okay, many things are asked. Okay, this formula I have copied down here. Mu1 is always 0, mu2 dash. What is mu2 dash? Here, mu1 dash is 2, mu2 dash is 20, mu3 dash is 40, and mu4 dash is 50. Okay. Now, mu2 is mu2 dash is what? It is 20 minus mu1 dash is 2 square. 20 minus 4 is 16. Okay, 16 is the second moment about the mean. Now here also you can put the values. Mu3 dash is what? 40 minus 3 times mu1 dash is 2, mu2 dash is 20 plus 2 times mu1 dash is what? 2, no? 2. Is it? And what is it now? It is 40 minus 120 plus this is 8, 2 raised to power 3, 8 into 2, it is minus 64, is the moment about, third moment about the mean. Now likewise you put down the value here, mu4 is equal to, mu4 dash is what? Mu4 dash is 50 minus 4 times mu1 dash is what? 2, mu3 dash is 40, then 6 times mu1 dash square, okay, mu2 dash, what is mu2? It is 20, then minus 3, mu1 dash raised to 4 means 2 raised to 4, and this is coming to be, it is 162. Means mu1, mu2, mu3, mu4 are the moments about the mean we have calculated. Moment about the arbitrary point 5 given to you. Moment about the mean we have found. Now, mean is equal to mu1 dash plus a. First moment about this is 2 and a is what? 5 and it is 7. Okay, this is the mean value of the data we have found. What is the next thing? The standard deviation. It is the square root of variance, and the second moment above the mean gives us the value of the variance, which is 16, and the standard deviation is 4. Okay, second moment is related to what? Variance. Third moment is related to skewness, and fourth moment related to the kurtosis. Okay. Next thing is to find a coefficient of skewness. Now, coefficient of skewness I am going to find. That is what it is denoted by beta 1, mu3 square by mu2 cube. Mu3 square means minus 64 square by mu2 cube. Mu2 is what? 16 raised to power 3. Okay. This is 64 means 16 into 4, 4 square is 16 and it is equal to 1. Coefficient of skewness is 1. Now, the coefficient of the measure of skewness, you know, it is the measure of skewness, and the coefficient of skewness is under root of, that is denoted by gamma 1, and it is under root of beta 1, and under root of 1, beta 1 is 1, which is equal to 1. Now, coefficient of kurtosis we have to find. The measure of kurtosis I am going to find out is, what is the measure of kurtosis? Beta 2 formula. You can see this is the beta 2 formula, mu4 by mu2 square, mu4 by mu2 square, and mu4 by mu2 square, and if you try to find out it is 0.63. Beta 2 is less than 3, then this data is what? Platypurtic. Okay, means data is more flat, because this is less than 3. Yes, I am writing here less than 3. It is what? Negative skew. In this way, we have solved the problems of moments in examination. So this type of problems are asked. Here, mu1 dash up to mu4 dash are given, mu1 up to mu4 we have found, and here the data is given to you with frequency, and mu1 dash, mu2 dash, mu3 dash, mu4 dash we have calculated. After that, mu1, mu2, mu3, mu4 I have calculated. Beta 1 also we have calculated, and beta 2 I have calculated. Here beta 2 is what? It is less than 3. Therefore, it is again practical. So we stop here. Thank you very much.